Hey everyone, Christian here, and today I'm very excited because we are talking about Kubernetes. In this video, I will explain to you what Kubernetes is and why it is such an important technology every IT guy should learn nowadays. We're going to deploy a Kubernetes environment in the cloud, deploy a simple web server application to get you familiar with it, but I also will explain some of the fundamental architecture of it and how the magic really works inside. And as you can imagine, that's a lot of stuff we will need to cover today. But first of all, if you want to know how to securely manage all your Linux servers and your Kubernetes cluster, then take a look at the sponsor of this video, Teleport. Teleport is an open source access proxy to manage your server environment, such as Kubernetes clusters, Linux servers, applications, and databases. You can protect it with two-factor authentication and an audit logging to record all the sessions and log user actions. You can install the free Community Edition completely self-hosted at no cost. There is no sign-up needed anywhere. But if you want to use Teleport within your business environment, they also offer an enterprise version with 24/7 support and Active Directory integration and much more. So if you're interested, just reach out to the Teleport team. I've put your link to their product in the description down below. So let's start with a tutorial and first understand the importance of Kubernetes for the whole IT world. Because we as IT guys, we all hear those buzzwords like Docker and Kubernetes all the time. And you might wonder, why should I use this stuff? And is this really such a massive thing in IT? And if you're still asking yourself these questions, then let me tell you this. Nearly all enterprise companies I've worked with in the past 2 to 3 years are all running some kind of containerization environment like Docker or Kubernetes. And this is also in line with the Gartner's prediction that by 2022, more than 75% of the global organizations will be running containerized applications in production. And that's really a huge increase from only 30% this year. And what we can learn from this is that Kubernetes and containerization are still pretty new technologies that are not adopted by all companies yet, but they probably will be in the next years. And if you want to stand out from the crowd and stay competitive in your IT career, it's just logical that you need to start learning these technologies. In other words, this is an evolution or a transformation that's happening in IT. You can nearly compare to what virtualization has brought to us. And we as IT enthusiasts, developers, sysadmins, or even on the help desk, we all need to learn this stuff. Can I emphasize it even more how important that is? I don't think so. So Docker, Kubernetes, cloud computing, all these things are important. And if you're not familiar yet with Docker, you never heard about it before, then you should start watching some of my other videos about it. I've made many videos about Docker, management of containers with Portainer, and so on. And of course, I've put you a playlist to learn all the basics in the description down below. So definitely check it out if you never heard about containerization before starting with Kubernetes. Okay, so we now understood that containerization and Kubernetes are a big deal in IT, but why? So what makes this platform so powerful and special? Remember, with containers we are able to easily deploy applications in an isolated environment that's very efficient and powerful. And containerization makes many things easier for developers and also for the operations guys. But it has a very big challenge, because in large environments a single server might not be sufficient to run all your containers. Especially when you need to run services for many concurrent users or workloads, handling all these requests becomes very tricky, even for the biggest and most powerful servers. So it might be a good solution to distribute our containers not just to one single server, but instead deploy them on multiple servers, also called a cluster. Because then we can utilize all the server resources more efficiently, and we also add high availability to our deployments. For example, when one of our servers needs to be updated or there is a problem, our application should be still up and running because it is distributed to other servers which can handle the additional workload. So this concept is also called scaling in cloud computing, more precisely scaling in and out. But you can imagine that it's not easy to manage this setup, as we are facing some additional challenges. For example, how do we handle all this traffic? When the traffic comes in, we need to somehow manage the traffic and route them to all our servers instead of just one. And that needs to be somehow automated and smart enough to detect if a server is offline and the traffic needs to be routed to the different nodes. We also should have some kind of shared storage where all our containers can access the same dataset. Because when our application that's running on the first server needs to write some data to the storage volume, that also should be updated for all other containers, right? And that's exactly why we have Kubernetes. Kubernetes is what we call a container orchestrator, a software that manages all this stuff for us and even more. So to understand how these magics really work inside, let's take a look at the architecture of Kubernetes. And I try to simplify that a little bit for us guys, but still give enough insight to understand how the different components of a Kubernetes cluster work together and how the solution works as a whole. So at the highest level, a Kubernetes cluster always consists of a master and at least one worker node. And the master's job is to run most critical components of Kubernetes cluster, and as the name would suggest, it's also the controlling part for all the worker nodes which will run our applications. But let's take a closer look at how the whole system works. So inside the master node, we have several components that have different responsibilities, and some of them can also be deployed in a high available fashion. So usually the master is not just one single server, it is also a component that could be clustered, but just to simplify it, we're taking a look at the master as a single entity. And let's start with the different components. The first one is the etcd, and that's a simple distributed key value store where Kubernetes stores all the data, such as several workloads, their state, the namespaces, configurations, and so on. So it's only accessible from the API server for security reasons. So whenever something needs to be stored inside the database of Kubernetes, or you're making changes to the environment, every communication is going through that API server. And the API server is the central management entity that receives all these requests and act as a front end to the cluster. So there are many different ways of how you can connect to this API. There is, for example, a terminal client existing. We're taking a look at this later. Or there are other web interfaces that you could use. No matter how you're managing the cluster or how the cluster is receiving data, it's all going through that API server. Then we also have the controller manager, and this runs several workloads and processes in the background, so it regulates the shared state of a cluster and performs some routine tasks. For example, when you replace a container image on one of the worker nodes or change parameters inside the configuration files, the controller spots these changes and starts instructing the other components what to do. So in case you start a new application on the worker nodes, the controller manager will instruct the scheduler. And the scheduler is a control plane process that assigns the resources on the nodes. So it looks at which nodes have available resources left and if it needs to move some resources away to other nodes and so on. And on the nodes, we are running two essential components and of course our workloads. The kubelet is the main service on a node, and that's taking instructions from the API server and making sure that all the workloads are healthy, so that all the containers are running in the desired state, that there are no problems and so on. And it reports the status to the master. So it's not making any decisions, it's just taking instructions from it and executing them. The proxy service that's also running on each worker node deals with all the networking and exposing services to the external world. So for example, when someone wants to access your application and workloads, the proxy is handling the traffic and making the changes in the operating systems to receive those connections. And the workloads then are running in containers, but the Kubernetes introduces another term that is called a pod. And a pod is the smallest entity in a Kubernetes cluster, and it consists of at least one container. But technically, it could also run multiple containers. So usually there's mostly just one container running in a pod, so it's not like a Docker Compose stack where you are defining templates. It's not what you should do. So it's more for a temporary configuration or helper containers that you sometimes need. But you typically would still define a database and a website container in two separate pods. Okay, so this is the whole architecture of Kubernetes, and I try to explain it in simple words, but don't worry if you haven't understood all the necessary details, because you will always deal with some kind of abstraction layer in Kubernetes. So you just define your instructions and what your desired state should be, and the Kubernetes cluster, the master, and all the different components make sure that this desired state is achieved. So Kubernetes is not a single component, it's a framework to implement container solutions that's very flexible and also extendable. And many third-party vendors have started to write their own extensions and implementations for Kubernetes, and that makes it extremely powerful, but also overwhelming when you see it the first time. So because all vendors have found their own ways of doing things, and it can be hard for a beginner to know what you should use and how you should use it. So it's kind of like Linux distributions. While they all share the same core, the Linux kernel, the community has built different software packages around it, different ways of implementing stuff and so on. So Kubernetes is the core technology, the framework to orchestrate containers on a server and how these components are managed together, but there are different implementations of how you can set this up. And this part will confuse and scare many people, just like me. I was very scared of setting up Kubernetes, but it's like with any new technology. Once you get used to it and you just try it out yourself, it will become less scary. So I just recently migrated my website and blog, The Digital Life, to a production Kubernetes cluster, and it was somehow painful to get through the basic hurdles. But once I understood all the pieces and how the parts fit in together, it's making things a lot easier for me now. So I can just encourage you to set up your own Kubernetes environment and play around with it. The easiest way is to set it up in a public cloud. Because the different public cloud providers all have their own integrated frameworks of managing and deploying Kubernetes for you. And that's exactly how you usually would do this in production environment as well. So on DigitalOcean, for example, there is an easy option to deploy a Kubernetes cluster with just one click. By the way, if you want to try out DigitalOcean, I have a referral link in the description down below. There you will get $100 for 60 days completely for free, and you can just use these free credits to set up Kubernetes and try it out yourself. So you will find that in the description down below. And that's exactly what I'm going to show you in this tutorial, because it's just the fastest way to get started. But I will make more videos about the different deployment scenarios of Kubernetes. We will also cover K3s, which is a lightweight version of Kubernetes made by Rancher, and that could be easily installed on your own environments like virtual machines, Raspberry Pis, and so on. So if you don't want to miss that stuff and these videos are helping you, then please do me a favor and hit that like button, and of course subscribe to the channel. Okay, so let's start creating our Kubernetes cluster on DigitalOcean. And there are, of course, other cloud providers existing where the experience of setting up and running a Kubernetes cluster is very, very similar. But because I'm just running all of my resources on DigitalOcean, I'm using this as an example. So in the web interface of DigitalOcean, we can just click on Create, where we create all of our cloud resources, and click on Kubernetes. And here we need to pick a version and our desired data center region. In my case, I'm picking Frankfurt, of course. And then we need to set up the cluster capacity. So here we can define how many worker nodes we need and how powerful they should be. So you don't need to care about the master. And this is the beauty of the cloud deployments, because on DigitalOcean and other cloud providers, the master node is running in DigitalOcean's cluster, and you don't need to care about this. You just define how many worker nodes you need, and DigitalOcean will manage all the different things, the nodes, the master, and all services completely for you. On DigitalOcean, you can also run a Kubernetes cluster with just a single worker node, but note then you don't have a high available setup, because if you set this node down for maintenance or running updates or troubleshooting things, your applications couldn't run somewhere else. So if you want to have high availability, then pick at least 2 worker nodes. And you can also set up the machine type depending on how much resources you need. You can set up basic nodes, the premium Intel and AMD CPUs, which are a bit stronger usually, or CPU optimized, memory and storage optimized nodes. In this case, I will just pick some basic nodes and use the lowest configuration. So note, the monthly rate $20 are not the only costs we have when running a Kubernetes cluster in a cloud, because we also need to pay for any cloud storage we are using and for load balancers as well. So this is something you should keep in mind. And now we need to also choose a name, for example, test cluster, and select a project. I will just use testing here. And now DigitalOcean will deploy all the different servers, the worker nodes, and the services that are running on it. And while this is running in the background, we can already start configuring our access, because when we are managing a Kubernetes cluster, I'm not using a web interface, I'm using the terminal client, the official Kubernetes client, which is called the Kubectl. So here we can just click on the link and just install the tools. If you haven't already done it, you can just follow the instructions here and install the Kubectl on Linux, macOS, and of course Windows as well. So you can see I'm currently running this in WSL, and I also have installed a very nice extension for the kubectl command that is running in the ZSH shell that will show me to which Kubernetes cluster I'm currently connected and in which namespace I'm currently working. So if you want to get the same development setup like I do, then just take a look at my video I've made about it. So there I'll explain to you how to set up WSL, how to install the ZSH shell and the themes. It's all documented in the video, and on my personal GitHub page you can find all the templates and my configuration files. So if you want to get that, I've put you a link to all this stuff in the description down below. So when you have downloaded the kubectl command and you can execute it, you first of all need to set up your configuration file to get access to your Kubernetes cluster. So let's go back to the DigitalOcean web interface and download the configuration file. So in the next step, you can simply just use the doctl tool, the terminal command to manage DigitalOcean cloud infrastructure, or you can simply manually do that and download the cluster configuration, which is a YAML file, and that YAML file contains all the cluster resources, the context, the certificates, and basically everything that you will need to access your cluster. So protect this YAML file as you would protect your root password, because this gives anyone access to your Kubernetes cluster. And when you downloaded the YAML file, you will need to put everything that is in this YAML file into your kubectl configuration file, which is usually located into your personal home folder in the .kube directory. So if you're managing multiple Kubernetes clusters, make sure that you're not overwriting these files, but instead add those entries that are included in this YAML file to the configuration. But because I'm just managing one Kubernetes cluster, I simply can just replace this file. And then you can also check if the configuration was applied by executing the kubectl config get clusters command. And then you can see that our configuration only contains the do Frankfurt 1 test cluster configuration that we've just downloaded and replaced. So now if our cluster is ready, let's start querying some resources and see if we can connect to the cluster. So let's enter kubectl cluster-info. So this will print all the information how to connect to our cluster. You can see the control plane is running at this location. The core DNS is running, so everything is fine and we can start querying some information. The first command I want to show you is the get command. So to get any information about resources in the Kubernetes cluster, we can use the kubectl get command and then name the resource you want to get. So for example, let's just get the nodes. And when we execute that, you can see that there are 2 nodes that we have just deployed in our Kubernetes cluster. Everything is up and running and we are fine. So now if we want to get resources, we can also use the same command kubectl get, and instead of nodes, we simply can just name pods here. And you can see that there are no resources found in the default namespace. So this is the next concept I want to explain to you because I haven't explained it in the architecture diagram. So when you are running Kubernetes clusters, when you are deploying many resources, for example, in a big environment, you could easily define up to thousands of resources. You need to somehow organize them. And one way to do that in Kubernetes is by using the namespaces. So usually you're always by default working in the default namespace, and we haven't deployed a resource there yet. And when you're querying resources, you're only querying these resources in your current namespace where you're working. But because we're also running some other namespaces in a Kubernetes cluster, we might have resources deployed somewhere else. So if you want to get all the pods, no matter in which namespace they are located, you can use the same command, kubectl get pods, but add in all namespaces at the end. And now you can see that there are some pods actually running in our Kubernetes clusters, but they are running in the kube system namespace. So the kube system namespace is the namespace where Kubernetes runs their internal system resources, so you shouldn't deploy your custom workloads there, but you can also technically see that there are pods running here, just as you can remember from the architectural diagram that kube proxy is, for example, running in this namespace. So if we now want to deploy our own workloads, we usually can create them in the default namespace, but I also would recommend you to create a custom namespace to better organize your resources, right? So let's just create a new namespace for all our resources. And I want to deploy a very simple web server with Nginx just to demonstrate to you how that works. So let's first create a new namespace by entering the kubectl create namespace. And for example, let's just name this web server. So now we have defined this web server and we can now start creating our resources. So if we now will get or create resources, we still will work in the default namespace. So to switch to the web server namespace, we need to change our configuration. So let's enter kubectl config and then set context. and then select the current namespace to web server. And now when we enter kubectl again, you can see that my extension will also show me that I'm currently working in the test cluster, but in the web server's namespace and not in the default one anymore. And now we can actually start running some workloads. So in Kubernetes clusters, there are many different ways of deploying and running applications and services. The very simple method to run a pod in a Kubernetes cluster is to use the kubectl command and then run nginx, and we also need to set up an image nginx. So this will simply just create a simple pod that will run on our Kubernetes cluster. So you can see that when we execute kubectl get pods, there is a pod that is currently up and running. And we actually don't know where this pod is now running. Is it running on the first node? It is running on the second node. That is what Kubernetes is doing automatically for us. But we can also extend this command with the -o wide parameter, and then we can actually see, okay, so this pod is currently running at this specific node here. So note there's also a second way of managing deployments in a Kubernetes cluster, because these commands are very static, such like compared to Docker commands. But there's also a way of defining deployments in YAML file, similar to Docker Compose files, for example. This will manage deployments more dynamically, and we can also adjust different parameters like replicas and so on, and define them in those YAML manifests. Those YAML manifests can be defined for all the different types of resources, not just for deployments or pods. But I will show you that in a second. First of all, let's just delete this pod with kubectl delete pod nginx. And if you don't want to create these manifest files from scratch, I've also created a repository on my personal GitHub page that is called Boilerplates. And there I store all the different templates for different DevOps tools that I'm covering on my channel, such as Ansible, Docker Compose, Vagrant, and also Kubernetes. So click on Kubernetes and go to the templates section. And there you will find templates for different types of resources. For example, the deployment that we're using to deploy workloads here, but also the service, persistent volume claims, and I will constantly add many more templates to this once I have time. So don't forget to follow me on GitHub, and please give it a star and rate this. This would really help me out. So to deploy a new workload here, we will use a deployment YAML template here to deploy a manifest here for our application. And we will just copy all this stuff here and create a new file and edit it in Visual Studio Code. So now this may look a bit complicated to you when you see it the first time, but don't worry, it's actually not so difficult. We can also delete a few things here that we actually don't need for a short presentation. For example, we don't need persistent volume claims here, and we also don't need any resources here. So we can just get rid of this, and now we can customize our deployment. In a Kubernetes YAML or manifest file, we always start with an API version, and that is depending on which kind of resource you want to deploy. So for application deployment, you will usually use the apps version 1 API version, and you also define the kind of resource with this parameter here, kind deployment. So now we can specify the specific metadata here. We can also set up the namespace here. So remember, we have created the namespace web server here. And we also want to set the name for our deployment to web server. We can also set up a label here and just replace everything with web server. So this is something I will show you in a second. And when we go down here to specifications, we can also see that in the container specification, we can now define which containers we want to run in our pod. So Kubernetes will create a new pod for this deployment here. And we can define that we want to run an nginx web server here, for example, by just replacing this first container here with the image and name nginx. And we also want to expose this here on the pod 80. So note, this container pod doesn't expose the application to the public internet. It just exposes it to the internal cluster IP, but I will also show you that. So let's just save this file and deploy this here by executing the command kubectl apply. So with that command, you can apply any manifest file. And let's also name this file deployment here. Let's hit enter. And now Kubernetes has created a new resource that is called a deployment. And a deployment will always create the desired number of pods, depending on how many replicas we actually need. And when you execute this command, you can see that there is a new pod that is called web server created that is currently up and running. And it has a cluster IP as well. So the cluster IP is only accessible from within the Kubernetes cluster because this is an internal IP address. And if you want to make those applications available to the public internet, you will need to define a service here. And a service is also another deployment we can define in a YAML file, so let's also do that. Let's go back to my GitHub repository, and there you will find the deployment template for a service here. So let's copy all this stuff, and in Visual Studio Code we can add it and customize this YAML file. So you can see the API version is here, no, just version 1, and the kind is a service. And we also want to replace the service name here with webserver service, for example. And we want to deploy this in the namespace webserver. So now we need a selector here to select to which application or to which deployment this service should apply. And now remember, when we go back to our deployment YAML, we can see that we have set the app label to web server. So we just need to use the exact same name here in the selector app to match the service to our pods. And now we also want to expose this service to the public internet. So there are different types of services. You can see in the template I included a simple explanation here to the cluster IP. So means this service can be accessed by any pod in the cluster, or the node pod, which means the service is only accessible by pods within the same namespace. And if we would expose this to the public internet, we usually would do this via a load balancer. So let's just remove these commands. We want to set this type of a service to load balancer. And we also want to expose the port 80. So the target port and the TCP protocol are optional. We don't need that. Remember, we have used the port 80 in our deployment file. So let's save this and try to apply this service here. So let's enter kubectl apply service.yaml. So we can also query those resources here by just executing kubectl get service, for example. And you can see that our load balancer is currently creating. You can see there is an internal cluster IP, but there's also an external IP that is currently pending. So why it is pending? Because the load balancer is currently creating on DigitalOcean. So when we go back to the DigitalOcean web interface here and go to the networking interface, you can see that DigitalOcean has integrated the load balancer manifest file with their own integration of a load balancer that you can manage in the DigitalOcean web interface. And you can see that this resource is now currently created. And this is because I said the $20 per month are not the only costs, because for every load balancer in the DigitalOcean, you need to pay at least $10 per month. So that is something you should always keep in mind. And if we reload the command, you can also see that we now have an external IP address. And if we enter this IP address in our web browser, we can now connect to our application. So this is awesome, right? So now if we go back to our terminal and get the pods, you can see that we currently are only running one pod. And of course, we probably want to increase that to get high availability, because if one node is down, the node where this pod is currently running, our application would be down and not accessible from the public internet. So to do that, we can just simply edit our deployment. And this is why I'm using these manifest files instead of just kubectl run commands, because then I can manage all my deployments in simple manifest files, and this is an easy way to do it. So let's go back to our manifest file of the deployment here, and to increase the number of pods the application is using, we can simply just increase the number of replicas here. And the Kubernetes cluster will manage all this stuff for us. It will automatically define so on which nodes there are available resources left and where to run those pods. We don't need to take care of this. So let's just increase the number of replicas, for example, to 4. And let's update our manifest file by just executing the same command kubectl apply-f deployment. And you can see it doesn't create a new resource. Instead, it recognizes, okay, there's already a web server deployment existing. I need to reconfigure it. And if we now execute kubectl get pods, you can see that there are 4 pods up and running now. So this is great. We can now access our application, and if we execute the same command with the white parameter, you can see that the scheduler has defined to run 3 pods on this node and just 1 pod of the application on this node. Probably because this one has not so many resources left than the others. So Kubernetes is self-maintaining and self-managing all this stuff. So let's try to shut down this node, for example, and see what happens when a node goes down and how the application is working in a high available cluster. So let's go back to the DigitalOcean interface and let's go to the droplet and take it down. So when we now go back to the terminal and execute kubectl get nodes, you can see that one node is not ready. Kubernetes automatically manages and recognizes this within just a second. And let's see what happens. Let's execute get pods. And you can see that there are some pods shutting down, but there are already new ones created and running here because we have defined 4 replicas in our deployment script. And Kubernetes will always make sure that we have 4 replicas of the pods running. No matter how many worker nodes we have, no matter if there is a worker node down or something else happens on the node, it will always make sure that we have 4 instances of our application up and running. You can see there's an instance there and there are 2 of them. And if we go back to our web server, you can see the web server is still up and running. It was running all the time without any downtime. And this is how you can manage a high available cluster with Kubernetes. And this is actually the reason why we need this technology and why we are using this to deploy our applications. Okay, so it's important to know that we've just scratched the surface on Kubernetes. There's much more to learn about persistent storage, ingress controllers, APIs, and so on. But instead of squeezing that stuff all in a single video, I thought it would make just more sense to point you to some great resources that helped me learning this stuff, and you will find many good explanations there as well. And just like I said, I will create more videos explaining some of the details in the upcoming weeks and months. So once I've released them, I'm creating a playlist and put them in the description down below. The first resource I want to show you is the official kubernetes.io page, and especially the documentation here. So here you can read and learn about all the components of Kubernetes in much more detail than I've just explained in the first section of this video. Although reading might sound a bit dry and boring, it sometimes really is important to look up specific things, and especially the Kubernetes documentation tells you a lot about the general architecture and how things are working together, so you should definitely take a look at it. The next resource is Rancher, and Rancher is a Kubernetes as a service company. They're innovating and building products around Kubernetes. For example, they've built their own implementation of Kubernetes called K3s, a graphical user interface for Kubernetes that we're also taking a look in future videos, by the way. And they also have some great documentation about Kubernetes as well. So these resources I would definitely take a look at. They are really great to get started with Kubernetes and find more about the details. But don't be worried, of course I'll make more exciting videos and tutorials for you in the future. Okay, so I hope this video helped you to understand why Kubernetes is really amazing, and if you're not yet convinced, then just jump into some of my live streams. I'm live on YouTube every Thursday where we discuss these topics in our community, and it's always a lot of fun. So thanks everybody for watching. I hope I see you soon in my live streams or some of the next videos. Take care everyone, bye bye. And this is just awesome, right? It's like we are all a community of tech enthusiasts, and of course we like Linux, we like FreeBSD and all, but we don't force anybody to have the same opinions like we do. And I think this is really a friendly, peaceful and respectful community, and I just want to thank you so much for that, because this is really awesome.